Monitoring is arguably one of the most important aspects of any observability implementation. And at the center of any monitoring project are metrics. Most of the time, these metrics are created automatically by components of the infrastructure that you didn't write the code for it. But what if you would like to have more control about when those metrics are created and when their values are updated? In this video, I'm going to show you how you can accomplish this using the OpenTelemetry SDK for Java. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. In this video, I'm going to show you how you can use the OpenTelemetry SDK for Java to create your own metrics. Now, before we jump into the nitty-gritty details of the implementation, let me explain what situations might be interesting for you to leverage this capability. The first situation is when you want to create a metric that only makes sense to your use case. Let's say, for example, that you want to create a metric to count the number of times when a product is returned to the vendor. Clearly, this metric only belongs to your specific bounded context, and the probability of this metric to be reused to another bounded context is minimal, to not say impossible. The second situation is when you want to create a metric that properly showcases the utilization of a given resource. Let's use CPU utilization as an example. Most of the time, people use agents to periodically collect the utilization from the CPU from a given container, virtual machine, or bare metal host, and then store those collections into a time series database. Then they're going to use some sort of a visualization tool to make inferences about the CPU utilization and the execution of applications and microservices. But the word here is inferences because they cannot possibly say with 100% sure that that amount of CPU utilization belongs to that microservice or application. It could be something else. That explains situations, for example, when the CPU is blamed to be the responsible for some microservice that is underperforming, and at the end of the day, you find out that it was due to some sort of a latency in the network or perhaps some hiccups in the backend systems. In order for you to create a more concrete view about utilization of a given resource, the better approach is to create a metric that computes and updates the value of that metric as your code executes. In other words, the metric is updated concurrently with your application code. But as people say, talk is cheap. Show me the code. Let's take a look now at how you can accomplish all of this using the OpenTelemetry SDK for Java. Before we move forward, please note that the implementation of this microservice that we are using as example can be found on GitHub. Take a look here on the comments below and you will find a GitHub repository that contains the implementation of this microservice written in Java. Also, when you clone that repository, use that specific branch called Build on AWS tutorial. Now, in the previous videos, we're automatically instrumented that microservice that uses Spring Boot and Maven, but we also did a customization on that instrumentation that we've called manual instrumentation. That's where we came up with this component called tracer, and for that tracer, we're able to create our own custom child spans. To create your own metrics, the approach that you have to use is similar, but instead of a tracer, you're going to create something called a meter. So our first step is to create a variable that's going to hold the version of the meter that we're using. So just like we've done with the tracer component. So with that in place, we can create our own meter. And I'm going to place this meter right below the tracer that we've created in the previous videos. So as you can see here, the meter is created just like the tracer. You invoke this Java singleton class global OpenTelemetry, and then you invoke the meter builder. You provide a name for that meter for the sake of troubleshooting purposes. If you want to troubleshoot which specific meter is causing problems to your code, etc., etc., and then you set the version and build the meter. From that meter, you can create two types of metrics. The first type of metric is what we call a static metric. So it's going to be the ones that you're going to create a specific variable to hold the state and the value of that metric. And the second one is going to be a type of metric that you don't necessarily have to create a variable to represent that metric, because that metric is going to be continuously updated in the background, and you're going to basically provide for them a callback function or method that is going to perform the computation of the new value. We're going to create these two types of metrics right now. So let's start with the type of metric that is static. Because it is static, we have to actually create a variable that's going to hold and contain the information about the metric. So in this case, we're creating a metric called number of execution. That's, as the name implies, is going to count the number of times that the microservice executes. And it's going to be of type along, because it's going to be a number. So this is a type of metric that we call the monotonic metric, because the value only increases or decreases. You cannot possibly have like variations, and it's always moving forward. So it is exactly the use case for counting purposes, right? Now that we've created the variable, we actually have to initiate that variable. So for this, I'm going to use a Spring Boot construct called postConstruct. And the postConstruct is a type of callback mechanism that you can use in Spring Boot applications that is going to be executed right after this Java object is created. So it's going to create the entire Java object, and it's going to automatically execute this method that we've called create matrix, right? So this create matrix, you can think about this as some sort of a callback that occurs right after the execution of your instantiation of your Java or Pojo. So in the create matrix method, we're going to actually initialize the number of executions variable. So as you can see here, we're executing this from the meter that we've created before. So from the meter, you're going to invoke, there are different types of metrics and data types that you can use. There are longs, there are counters, there are histograms. If you go to the OpenTelemetry specification project, specifically for metrics, you're going to see that there are multiple types of metrics, monotonics, non-monotonics ones, that you can leverage for your implementation. In this case, we're creating a counter, and the name of this metric is going to be called custom.metric.number.of.exec. This is the unique name that we're going to give to this metric. And you can actually also set a description for the metrics. And also optionally, you can set the unit. The unit is not something that you have to kind of religiously take for granted. It's not necessarily because you say here that's going to be an int that this variable or metric is going to behave like an int. It's more for, remember, observability is all about what you do in your code to make your code observable for the backend, right? Or for whoever is looking to the observability backend. So it's basically a hint that you are giving them about what is the nature of that metric. So this is, you can see this as a best practice more than actually a step of the implementation of a metric. And then we're essentially build that, that metric. So from this point on, the metric is created, and it is up to you to update that metric. So in our case, we're actually going to update, and that's why we said that this type of metric is static, because the characteristic of static metrics is that you have to manually update their values. So now that we've created the number of executions, we're going to update this matrix right here. And as you can see here, we're actually updating, incrementing the value of this metric in +1 right exactly when this microservice executes the function hello, which, as you may recall from previous videos, is the entry point of the execution of that microservice. So along that's the beauty of this matrix created with the OpenTelemetry SDK. Along with the execution of the code, you are going to increment that value, so you can be absolutely sure that whoever is looking to the observability backend and seeing and kind of follow up with the increments and decrements of that metric is going to be sure that that occurred exactly in the exact moment that your microservice or code in general is executed. And that's the beauty of that practice, instead of reusing some sort of a generic metrics that agents create for you automatically. So in this case, just to recap, we're going to update the value along with the code. And then we're creating here a second metric that we're giving the name custom.metric.heap.memory. So What is the purpose of that metric? That is going to be a simple metric that calculates the amount of memory utilization from the JVM heap, right? Which is some sort of a very interesting metric that you could use it. But here's the magic of it. This is going to be a metric that is going to automatically update in the background without you actually forcibly update the metric. So this is what we call the automatic metrics in the OpenTelemetry SDK word. So as you can see here, we're creating a gauge or gauge. Let me know in the comments how we better pronounce this. I always call it gauge because of my heritage and from Brazil, but let me know if the correct ways to say this is gauge, because a friend once told me that's the best way to do it, but my brain still thinks about how Brazilians pronounce things. So forgive me about that. And then the name of the metric, as I said, is going to be custom metric heap memory. You set a description. You can, as a best practice, you can set the unit of it. And then here's the interesting part about this type of metric. We're providing a callback or a function that is going to be used in the background by the OpenTelemetry agent engine to compute the value of that metric. Now, here's the interesting part. When you use and create metrics in OpenTelemetry, there is an interval when metrics are computed and flush it to downstream or whoever exporter you're using. So right now, if you recall, we're exporting all the metrics to the logs, right? So by default, the OpenTelemetry specification dictates that every 1 minute or 60 seconds, that's when this is going to occur. And the same default we can use to understand how frequently this callback method is going to be invoked. So every 1 minute in the background, the OpenTelemetry agent is going to invoke that function over here that's going to basically compute the total memory available for the JVM, and then it's going to subtract of the free memory available. So that's going to be the memory used from the JVM here, right? So, and the value, the remaining value is going to be set to that specific metric that we've created. And this is a non-monotonic type of metric. That means that sometimes the value can go up, and sometimes the value can go down, specifically when the garbage collector is executed and is going to free up some available memory. So you're going to see in the graph in the next videos that you're going to see a more like a concrete view of the JVM utilization. But the beauty of that approach, again, is that this metric is being updated concurrently with your code. That means that you can be absolutely sure that what you're seeing in the observability backend is the reflection of what your code is effectively doing. There will be no inferences about this value, right? So now that we have created the two metrics, what we need to do right now is to re-execute the microservice, and we need to send a couple requests to it so we can check if the metrics are being computed and generated properly. However, we won't be able to see the metrics at this point because, again, the metrics are being sent to the collector, and the collector currently is configured to flush all the metric information to the logs, as you can see here in this file, collector config local. So the exporter that we've created called logging is being used here on the service pipeline for metrics. So as the receiver, we're going to receive all these metrics in the OTLP protocol, and we're going to export these metrics to the log. To make things actually more interesting, in the next video, I'm going to show you how to configure this collector to not flush the metrics to the logs, but to store these metrics in Prometheus. And then we're going to be able to visualize those metrics using Grafana. So I'm looking forward to see you in the next video.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.